Welcome back, everyone. In this video, we're going to be talking about acid-base titrations. And this wouldn't be an introductory chemistry course if we didn't talk about titrations at some point. Well, what is a titration, you're probably wondering? Well, it is a very common procedure performed within the field called analytical chemistry. Every high school chemistry student somewhere in the world is going to be doing a titration at some point. Now, thanks to COVID-19, we can't be doing titrations in the lab, but I can at least show you how they work. And whenever we go back to school, we'll be doing titrations in the lab. So what are we doing in a titration? Well, in a titration, we are actually trying to determine the concentration of a substance, some substance that is of interest to us. And we're going to be using stoichiometry to determine the concentration of this substance. Titrations are really at the heart of a lot of different tests. And a breathalyzer test that you do to test for alcohol content is a type of titration. It's not an acid-base titration in the way that we know acid bases, but it is a titration. You can use titrations to determine the concentration of, let's say, vitamin C in orange juice. You can determine, the concentration of an acid that might be present in a sample of water. You could use the titration to determine the concentration of iron ions or the concentration of any other metal ion in some sample of fresh water. So there's lots of little things you can do with titrations. As I said, they're a very common analytical procedure. So in this video, what I'm going to do is I'm going to kind of show you what's going on in a titration and how the titration works. All right, so here is an acid-base titration. And to start us off, I'm just going to go over some of the vocabulary involved with the glassware. So every titration setup involves a burette. It's called a burette, B-U-R-E-T-T-E. And we have a flask, specifically an Erlenmeyer flask. And in the burette, we have a certain volume of what we call a titrant. And the titrant is a substance, the reactant in our chemical reaction, for which we know the volume and the concentration. So we know everything we need to know about this titrant, okay? This is the thing that we know the concentration of. So in this case, I'm going to pretend that this is actually the base. So it doesn't always have to be the base, but in this example, it's going to be the base. And in this case, we know its concentration. All right. In the Erlenmeyer flask, we have a sample of liquid, and it's usually about 10 milliliters of the liquid. Of solution, not technically a liquid, a solution, and we refer to it as the analyte. And for the analyte, we don't know its concentration. That's what we're trying to figure out. We want to know its concentration. It's a pretty useful technique, especially like, river water, or your drinking water. You want to know what's in there. And this is a technique that you can use to determine exactly how much stuff is in there. All right, so we got our analyte with the unknown concentration. We have a titrant with it, and we know its concentration. Our analyte here in this case is going to be an acid. And the last thing that we put in here is we put a pH indicator. And I'm going to use as a pH indicator bromothymol blue for this example. I'm not going to do any math for this one. There is going to be a fair bit of math when we do titrations, but that's for a future video. Bromothymol blue goes through a very distinct color change. For pHs up to about like 7, it's going to be nice and yellow. And then once it gets to 7, it's like this nice light green color. That should be green. And then after it, it goes blue. So when it's basic, it's blue. So it's really, the reason it's green there is because it's an equal mix of yellow and blue mixed to give you green. So right at green, we know that bromothymol blue is in a neutral solution. All right, so when we add some pH indicator to our Erlenmeyer flask, it's initially going to be yellow. And what I do as I perform the titration is I'm, on this burette, there's a little handle here called the stopcock. You can turn that, and as soon as you turn it, some of the titrant is going to start dropping down, and we're going to start adding it to the Erlenmeyer flask. And as the titrant starts coming out of the burette and starts mixing with the analyte solution, the chemical reaction begins. So we will have a base mixing with an acid, okay? And the base and acid will react together to produce the salt plus water. So the base will neutralize sections of the acid whenever its droplets interact with the surface of the acid. And a lot of times as you're doing this titration, you'd be swirling the flask, or you might have a stir bar in there that's constantly mixing the contents so that you get a good reaction going. Okay, so when you're doing a titration, you actually will be sitting there for a little bit, adding base, and you won't really see much of a color change because it remains acidic for a while, and you won't really see a color change until you add a certain amount of base. And that one, it changes depending on what the concentrations are of things, but at some point you're going to add enough base that your solution turns green. And at this point, this is what we call the end point. The end point is when the pH indicator changes color. And specifically, we're looking for the green color with bromothymol blue, because at the green color, this tells us that the acid and the base are completely neutralized. So however much acid I had in the Erlenmeyer flask, it has now been completely neutralized by the base that I added to it. And now what I can do, once you get to the end point where the pH indicator changes color, you can read off the volume that you added from your burette. So your initial volume of base, VI, was what you started with, and then you add up to the endpoint until the indicator changes color, so it's green, and that gives you your final volume. And that difference, let's see, the difference between the two, that's your volume of base. So if I know the volume of base after I get to the endpoint, and I know its concentration, so I know both of these things, I know the volume of the base, I know its concentration, together with concentration and volume, I can determine number of moles of base. I can determine the number of moles of the base. And here's the cool thing. If I know the number of moles of the base, and presumably I know the balanced chemical equation, I can take that number of moles of base, the stoichiometry the stoichiometric coefficients from the balanced chemical equation. I can take the number of moles, those coefficients, and I know the volume of the acid here is usually about 10 mils. I can actually then determine the concentration of this sample, the concentration of acid in this particular sample. So that's really what is going on in a titration. We're taking something for which we know its concentration, and ultimately we're going to know its base. Its volume. We know the volume after we get to the endpoint. And we're taking that information to determine the concentration of another substance. Okay. All right, now titrations can be kind of finicky. This is easily said, just getting to the endpoint, but it can get very finicky, and often it can come down to like a difference of a droplet or two, whether this is green or yellow or blue. It'll stay yellow for a long time, and then one or two droplets, and then it's green, and then if you add another droplet, that pushes it over into basic territory, and it goes blue. And at that point, if you get to this point where your pH indicator is now blue, that's not so good. That's called an overshoot, or you overshot the titration. You went too far. So this is like you added an excess of base. You didn't need to add that much. And this would, it might be a little bit lower than what you normally would have added to get to the neutral range of green. So this is not good. You don't want to get to an overshoot. But that being said, your first trial, you usually do like 3 or 4 trials of a acid-base titration. Your first trial is usually going to be an overshoot because you want to kind of quickly determine roughly how much volume you need to add of the base. Otherwise, if you go like drop by drop by drop by drop, that can take a long time. So you make your first trial an overshoot, and you get an idea, roughly of how much you should be adding. And then for your second, third, and fourth trials, you go a little bit slower, and you know to slow down at a certain point because you don't want to go too far into the blue range. All right. So all that being said, with your titrant, you can determine the volume of the base, and you'll know its concentration from before. You can use that information to determine the number of moles of base. You can then use the number of moles of base along with the coefficients from the chemical equation and the volume of the acid to then determine the concentration of the acid. And I'm going to be going through the math behind this and that thinking that I just outlined in the next video. But hopefully you kind of got an idea of what we're doing in a titration. And yeah, once again, it's too bad that we can't be in person to do these titrations because they are a lot of fun. They're very, very finicky, and it often adds to the tension. You want to make sure you get it just right. But that will have to wait for some time in the future. All right, I'll see you in the next video where I'll explain the math behind this.